radioactivity. How long does it take for radioactivity to decay? All right. We measure this in a really strange way. Okay. We measure it in what's called half-lives. Okay. I'm going to show you a video, but don't get so bent out of shape about it, and then I'll talk about it. Okay. There's some things that are there, and then there are some things that we'll ignore. Okay. But we talk about half-lives. So let's watch the video, and then I'll tell you what we're going to do with it. Okay, so carbon-14 actually converts to something else. And so what they are doing is they're measuring your sample, how much carbon-14 is left. Now, here's the thing about carbon-14. It's used to date, things that have carbon in them, like live things. And carbon-14 is in all of the atmosphere and in the food cycle. So everything has carbon-14. And everything has the same percentage of carbon-14 in your body, because carbon-14 is made in the air, and plants absorb the carbon-14, and the plants were eaten by the animals, and we eat the plants, and we eat the animals, and the circle of life makes everything mix up and be even. Okay? And so as long as we're ingesting food, we're ingesting carbon-14, and our levels stay the same until one point when we die. At that point in time, we're not intaking any more carbon-14. So we start with the average, and we start losing carbon-14 because we're not adding back anything in. And so what they do is they measure how much carbon-14 is left versus how much should be there, and then we figure out how many half-lives it takes to get there, and that's how they date it. All right, a little bit complicated. There's some assumptions in carbon-14 data, and carbon-14 data can't test the age of everything in the universe. Okay, it's the one we talk about, but it really can't go back that far in time versus what they believe the Earth is, at least atheistic scientists, from that perspective. There are Christians that believe in an old Earth also, but it can't go back that far. Okay, there are some issues, but what do we think about and how do we use half-lives? Okay, how we're going to use half-lives is kind of a little strange. Okay, but I want to show you what kind of problems you might encounter. Okay, and so if I do that, let's do something like this. Let's assume, okay, that you have, let's say, 20 grams of radioactive material. Okay, got that? Now, its half-life is, let's say, 5 days. Okay. How long would it take to have 2.5 grams left? Okay. So that's kind of a question that you might have. Use a question mark for a question. All right. To do this problem, you need a couple of things. You need the starting amount, and you need the half-life to solve this problem. And this problem gives those two. Okay? But you've got to start it in a way that you would never have thought about, okay, to get there. All right? And remember, what half-life means is you start off with a material, and in this case, 5 days, half of it is broken down into its daughter. It's not left, it's just changed into the daughter. Okay? And so, half-lives are like this. I relate this. I have 3 daughters and my wife, and we go shopping. And so sometimes they're great sales, right? There's 50% off. That's half, right? And so, but today only, you get an additional 50% off. So that means it's free, right? Isn't it? 50 off, and then you get an additional 50 off. That's free. That's 2 50s. Doesn't work that way, does it? Okay. So if something costs $10, 50% off is what? 5. And if you get an additional 50% off, it is 2.5 or $2.50. Okay. Now I'm happy when we find those kind of sales. Okay. But just 250% doesn't make it free. Okay. And it would take a lot of half-lives for it to be free, because another 50% off would only be $1.25, and another 50% off would be 62.5 or 63 cents, and then another half would be, it would take a long time for it to be absolutely zero, okay? And so it does take a long time to get rid of something by half-lives, okay? So here's where the weird thing starts that you would never assume. Whatever time unit you start with, the beginning amount, 20 grams, starts at, in this case, 0 days. That's weird. Okay, at 0 days, it's 20. That's how you start one of these things off. Okay, so how long is a half-life in this question? 5 days. All right. And how much do I lose every time? 20 goes to 10. All right. I'm not at where I want to be, right? So my next time period is, I total up now how many days? It'll go to 10 days. How much will now I have left? 5 grams. And then my next half-life is how many more days? It makes it a total of 15 days. And I am down to what? 2.5 grams. The answer to this problem is it takes 15 days, okay, or it takes 1 half-life, 2 half-lives, 3 half-lives to get to 2.5. So you could answer it in 15 days, or you can answer it in 3 half-lives. That will happen. The weird thing is this. We don't think about starting at 0 time period, and if it was years, it would be 0 years. If it's in seconds, it's 0 seconds. But that's what you need to do to set this up. This simplifies the math. Now, there's a very complicated equation that you could use. Well, let's not do that. Okay? We can divide by half. Oh, no, now I've asked you to divide. Okay? By 2. But I think you can do that. So we've got adding and subtracting and dividing by 2. All right? So that's what we're going to do with half-lives.